So as mentioned, Postgres is a program, right? So we have to download and install it. Some of you may have done this already. The 13th version of Postgres has been released, which is awesome. And one moment, I will be right back. Hey, so I've already downloaded Postgres, but just to point out, there's multiple ways to do this. You very well might use a package installer. I've installed a nice program for Postgres called let's see where, Postgres app. It's very friendly. I actually prefer this to Homebrew. I use Homebrew for pretty much everything else on Mac. Unfortunately, this one will not work for Windows, but it's great. I have this little elephant up here. It's gone. Oh, that would help, wouldn't it? Zainab, thank you so much. I was talking about all this stuff and it's like, where are the things? So Postgres app, Postgres, various download instructions. Postgres is one of those programs, honestly, I find it easier to just always leave running in the background. I think by default, Postgres app starts up when my computer starts. As mentioned, the program, it's actually a server. Like if I wanted to, I could have this over the internet, like expose it over the internet and people could log in. And these are a bunch of different Postgres databases that have been created over time with previous classes and things like that. And there's a graphical user interface, but as with almost all programming tools, there's also a command line interface. And I'm going to use iTerm. And the command line program is called PSQL, Postgres SQL. It has a very friendly type help for help, which is good because I always forget the commands. But /Q will quit. And so I already have PSQL installed. PSQL is a command line interface that talks to the Postgres server. If that's not running, I get an error. Connection to server on socket, blah, 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 blah. Is the server running locally and accepting connections? And it wasn't, and now it is. And probably setting up your Postgres server program to always turn on and always be running when your computer starts, honestly, I think just makes life easier and is what a lot of developers do with tools like Postgres that are sort of services. And you can do a lot of different things from the command line. I think I'm looking at a list of all the different databases now, and databases have owners and things like that. And I do want to create a new database. Let's connect to, let's see here. And we're going to do today and tomorrow some exercises with PSQL and Postgres on the command line because it is good to learn, even though we won't always be using it. But SQL is such a fundamental tool that it's very valuable knowledge. So we're going to create a database named movies in Postgres, in PSQL, and with SQL, every statement needs to end with a semicolon. And now if I do this /L command, there is a movies database. And if I use the /C for connect, I can connect to movies. And I'm also doing this as my user. And we can go ahead, there's multiple ways to create tables. I'm just going to create the movie table quickly, just as an example. I don't want to spend too much time doing this, but doing it from the command line, I can do create table movies. Because I haven't used the semicolon, I can still type out a little more code. Let's see, we've got the integer that our ID primary key and the text field. Let's try ID integer primary key. And then name text and semicolon to end it. And I have a syntax error, which is not uncommon. Sorry, Zainab?
You didn't put parentheses?
Oh man, okay. Yeah, this is also honestly why doing all this stuff from the PSQL command line is not the greatest. And there are much better ways to do this, but I really just wanted to kind of introduce this. And now I think that worked. And now if I do /D, I've got a movies table. The fun part really is the insert statement. Let's find just an example. And it should probably look something like this. Insert into the name of our table and our values. So insert into movies. And we just need to put the name of the movie because the ID is a primary key and Postgres takes care of that. And now if I use this select command and the star, which is sort of a regular expression. Oh,
yeah.
What did that not like?
Into movies with values. So there was a keyword values that you need to put for.
Yeah, thank you. This is. Let's try that again. And actually, let's see, column, I probably need to, let's try name. I think I'm being a little too.
So if you want to specify the specific columns, you have to put it before the values. So in the, so after movies, you can say name in parentheses, yeah. And then values.
Thank you so much. Now let's see if that worked.
No, it said that it's looking for a column with that name, which is not.
Maybe I was wrong and I do need to add the primary key. Maybe, yeah. I honestly, I should probably pause here because I will probably get lost trying to debug this. And it is almost definitely like a relatively straightforward syntax error. Which is a good reason to try and not live code stuff all the time. What also works though is I'm sure there is online Postgres SQL validator, or VS Code might even help us with this. Insert. I'm not sure if VS Code will help with that. Yeah, I'll circle back because this is definitely a syntax issue and not a major problem. And I mainly want to talk a bit about writing queries. And most of this we talked about, that the rest of this slide deck, and Jim, you kind of touched on this. Like, we don't want to duplicate information across multiple tables. And we already figured that out. Instead, we want to use foreign keys, like we are here, where address ID is a foreign key that references the primary key of this addresses table. We already talked about constraints and using not null if we want to. And let's talk a little bit about querying, which is really kind of what we'll be doing a lot of the time. And I was able to get that create table query running correctly, and I screwed up somewhere in the syntax for my insert statement, which is fine and which happens. And we'll mostly be either inserting a row, updating to modify an existing row, deleting a row, or using a select query to get information, to get rows from one or more tables. And Kayla, yes.
Oh, I was just gonna ask, I know we moved past it, but could the syntax error be because of the double quotes? Because I saw online that it said that single quotes and double quotes are used differently.
That is a great call. I think you may have just fixed it. Yeah, thank you so much. I was just seeing that in the chat too. That's awesome. Thank you. Yeah, so this is a good example of structured query language being a little persnickety and just one of the challenges of context switching. And Kayla, thank you so much for saying that, because I would have spent 10 minutes and not thought about the quotes, because I haven't written SQL in a minute.
Yeah,
And in fact,
it
sorry,
says that
go ahead.
double quotes are used to indicate identifiers like the tables and column names, and the single quotes are used to indicate string literals.
That makes sense. That I actually did not know that. That makes sense. Cool. Yeah, it's also, I will admit, I totally started going into sort of like throwing spaghetti against the wall mode there. I wasn't really thinking and listening when I was trying to debug then. I was just trying stuff and hoping it works. And now I'm curious if we really need to pass in the primary key or not. Yeah, there's probably a different rule that we can add so that it's the primary key is auto incrementing. And in fact, we probably should have made the movie name unique too, which I didn't think about. And I think what I'll do is, let's see, Postgres auto increment primary key. So it probably needs to be the serial data type. Serial is in like increasing, like a regularly increasing integer. So this should really look like, I want to say like that. And then for a movie, we probably do want the movie name to be, well, it's an interesting question if you want the movie name to be unique or not. And so I will let that one sit. Yeah, Kayla, that was awesome. Thank you. And now I've got, we should have two things in our movies table now. And now we can demonstrate a little bit. Like, people have been asking great questions, like, what if I only want part of the information that an API gives me? Well, you can't do that with an API, but with a database, particularly with a relational database, you can. Now, we don't have a lot in the movies table, but if we did have a bunch of stuff, we could just say we select the name column for movies. And maybe we want to do it where ID equals 1. maybe we want to do it where this is a little redundant and using the single quotes. I think actually it would be a little more interesting. Maybe we needed to get the primary key, the ID for Top Gun Maverick. And so select queries are where it gets really interesting. The star comes for regular expressions and it will give us all the columns on a table. And here we see an example like we just did, but they're using a students table as an example. And here's an example of, I want to get these two specific columns from the students table. And I think, we just kind of saw this. The where clause has a lot of interesting options. You can probably do some interesting stuff with dates with the where clause. Like we could definitely use the where clause to find all movies scheduled on a certain day or between two certain dates. And here's just a range of examples. And the nice thing about SQL is it is pretty readable, and that's why it's stuck around so much. It is extremely powerful. I will say, and Zainab, I know that you've worked a lot with SQL previously at Northern Trust. When I have worked with SQL, the query logic stayed relatively simple, and a lot of the times the complex logic would get moved up a level into the Python code calling the SQL itself.
Yeah, sometimes you don't have an upper level, so you have to write these things called stored procedures, and it's basically a bunch of logic that you have written that you can run like a function, and it runs through. You can have loops, you can have so some stored procedures that I've worked with merge like two tables into a new third table that so it creates a new table, and then it goes through all the data from two existing tables and kind of grabs what it needs, concatenates what it needs, and then it populates a third one. So it sometimes can get more complex if you are on a team that requires that and you're not using, like you said, Python or any other language to pull data from the database. If you're using those, it's usually easier. There's libraries that have been written that makes like querying so much simpler.
Yeah, that's a really good point about the team and the environment. And to go back to the example that we were using with AMC theaters, if you were on the team in charge of kind of owning the database of all movies showing at all theaters across the country, to run with what you were saying, Zainab, maybe your team writes a stored procedure that will get all movies showing today for a specific theater. And then my team that's writing the website that a user might use would call that stored procedure, where the user chooses a drop down to see information for a specific theater. And that's one example of how kind of the division of labor can work in a big environment. We saw the insert statement. We saw some of the gotchas of the insert statement. So I think there's not too much that we have to say here about that. And I'll make sure that these slides are available afterwards. Update lets us change data that already exists. You can use the update statement to potentially update multiple rows of data at once. Deleting is pretty straightforward. As we talked about, if you try to delete something and there's a constraint, Postgres, the database, won't let you. The same way that I kept getting all these errors here. If we try to delete a movie that's already scheduled, then we'll run into a problem. And I'm very tempted to try and like paste the code in and get that all working, but I haven't tested it out, and I will probably run into typos and issues along the way. So I'm not going to try and squeeze that in. This is just a gotcha to be aware of. Like the where clause is kind of where a lot of the magic happens with SQL queries, because that specifies what we want to change. You could potentially delete everything from a table or update everything in a table. And that's really it. That's sort of the main thing with SQL. I think the only thing that we haven't seen is what's called a join. And I think I'll just write out an example of that very quickly. And then we can kind of pause and talk about the afternoon. And I'll write it out and then talk about it. And I'm kind of looking at the example in the curriculum, by the way, and I'm kind of modifying it to work for our code. So I think what we want to do is we want to get all movies playing on a particular day. Let's say all movies playing today. And this is a good example too of how to like work through constructing a query like this, because I am working through and constructing it now. I would definitely start pseudocoding. And we need to think about the two tables that we need. We need to connect movies with schedule and filter by date. And a join joins two tables together. Let's see here. From movies. So let's select name from movies, join schedules on movie.id equals schedules dot, I think we called it FK movie ID. Where schedules and dot, and in fact, when you're writing these queries, this is getting complicated enough where I need to start breaking it out onto multiple lines, and SQL doesn't care about lines or white space or new lines, so that's okay. We're schedules, so dot showtime equals Postgres date function today. Let's try just, I'm not sure if this is proper Postgres, but it communicates the intent. So we kind of, so again, we're joining these two tables. And this is a lot of what you'll practice this afternoon. Kind of the key step is we have the two tables. We need to decide how to connect them. That's relatively straightforward because we know that our schedules table has a foreign key pointing to the movie ID. And then we need to filter. And again, I probably have some syntax errors, but this I think sort of like communicates the intent of like how you use what's called a join query to combine information with two tables and then filter it. And this is probably a good point to pause and check in and see what questions people have, and then also talk about the afternoon. So I'm curious, I just want to check in with the class and see if there are any things that it'd be good to go over or review, or just what's on people's minds. Okay, cool.